In these peculiar times where everything seems so relentlessly contingent, justifying science, despite the political parties harping on about knowledge economies and the like, can be tricky. Sure, you can spend time and money on a piece of research, but unless you can point to an outcome and say,
"This is the way my work could make everything better,"
then you could be in for a rough ride. Budgets are tight, patience is thin, and perceived indulgences are like kindling to the fire of public outrage. If a piece of research seems like a simple case of "core blimey, what a waste of time," then heckles immediately rise. Understandable, science is expensive and time-consuming, but the problem comes in knowing what is frivolous and what is not, what could yield something spectacular and what is a simple whim. Very often, something which can seem ridiculous, or at least is presented that way, holds incredible potential for real-world applications. So, I thought it'd be nice to highlight two pieces of core blimey, what a waste of time research and show how they have in fact deeply important applications. First up, sniffing bugs and a dodgy joke. My E. coli has no nose. How does it smell? Surprisingly well, due to a biomechanically complex system of histidine kinases. Since a study back in 2010, we have known that bacteria incredibly share with us a sense of smell. Now, in a new study published in Science, an international team has proposed the mechanisms for this. Using X-ray crystallography, they managed to crack the molecular ins and outs of NARC protein from E. coli, which belongs to a universal class of sensory histidine kinases. It is these which essentially act as the molecular nose for bacteria, allowing them to glean information about their environment. So far, so what, you might be saying? But look, as I reveal before your very eyes, a potential substitute for modern antibiotics. The team behind the work from the Moscow Institute of Physics and Technology say that with a better understanding of the mechanisms of signal transmission, we can expect to learn how to manipulate bacteria and, as a consequence, maybe even weaken the harmful effects of pathogenic microorganisms. Once you have a handle on the mechanisms of how bacteria sense, you can essentially trick the bacteria into a harmless state. We could, potentially, make superbugs smell their way into an inert state. Next up, cockroaches with personality. Scientists from Liverpool John Moores University and the University of Manchester have suggested, in the pages of PLOS ONE no less, that cockroaches' personality stays consistent. Yes, they have personality, and yes, amazingly, it stays consistent. Individual Pacific beetle cockroaches were placed in a novel environment, and their tendency to leave a safe shelter and explore was measured as both young nymphs and adults. It turns out that a bold nymph will make for a bold adult. All together now.
Core blimey, what a waste of time.
But not so, and here's why. Firstly is to highlight the sheer wonder that an organism as neurologically basic as a cockroach has such differences in response to their environment. Secondly is to understand that knowing this could uncover some of the deepest secrets of evolution. The role that traits like this play in the adaptive evolution of individuals and species is revealing much about the nuts and bolts of natural selection. Personality, it turns out, is an important tool in the game of life and has implications from medical research to animal welfare. And there you have, with a dramatic flourish of my imaginary cape, the profundity buried within the apparently banal. And all it takes is attention. Any piece of peer-reviewed science, if given due attention, holds incredible potential. Each a step on the long ladder of human understanding. A ladder that may well have no end, but is always worth the climb. And if all that sounds frightfully pretentious, then I can only apologise and blame the boldness of my personality. I was, after all, such a precocious nymph.